Hi, my name's Nigel Poulton, and together we're going to take a quick look at the Shellshock bug and how we can potentially use SELinux to limit some of the damage that the bug can cause. Now, I'm an IT trainer with Pluralsight, and I write a technical blog at nigelpoulton.com, and I host the weekly In Tech We Trust podcast. So that's me, but on to Shellshock. Now first up, Shellshock is looking like a pretty serious situation. Not only is Bash one of the most widely used and prevalent pieces of computer software on the planet, this is also a relatively easy bug to exploit. And the potential damage that can be inflicted here is honestly nothing short of staggering. The US National Vulnerability Database scores the exploit as a 10 for base, a 10 for impact, and a 10 for exploitability. So obviously an overall score of 10 as well. And like the screenshot here shows, that's not 10 out of 100, that's 10 out of 10. So as serious as it gets, right? Now quickly on the topic of how widely used Bash is, it's fair to say, I think, that Bash is the default shell or command line interpreter that ships with the vast majority of Linux servers in the world. And that's not even to mention Mac OS X, OS X, BSD based systems and more. But even that, we're not just talking here about what we might term regular Linux servers and the likes. We're also potentially talking here embedded systems, mobile devices, all of that kind of stuff. I mean, Linux and things like FreeBSD are massively popular as the foundation technology for a ton of other corporate and consumer technologies. For instance, a boatload of corporate networking technology is based on either BSD or Linux, as are storage technologies. Then there's home routers, mobile devices, the list's almost endless. Linux is widely used, and where there's Linux, there's a decent chance that there's Bash too. And it seems like pretty much every version of Bash is vulnerable, at least every version that's likely to be in use today. So I think from version 1.13 and upwards, everything is vulnerable. So it's not like we're talking about just a really old version here, or maybe the latest couple of versions. We're talking about pretty much every version of Bash. Okay, so let's take a quick look at the vulnerability itself. Well, we need to start with a quick bit of background. First up, Bash allows us to specify a function within an environment variable. Okay, what does that mean? Well, by default, in Bash, variables are strings, text, yeah? And it's perfectly valid for that text to be a function definition. So think of it this way, instead of creating a variable that's just got something like a regular string inside, maybe something like our name, our machine name, or even our search path, what Bash also allows us to do is actually define a variable to contain a function definition. Not to execute the function, but to define it. And all of that's fine. The bug in all of this is that following that function definition, so still as part of the text of our variable, we can add pretty much any code we want. Now, the security folks like to call this code injection, and they use terms like arbitrary code and malicious code. Scary stuff, right? Basically meaning an attacker can add any code that he or she wants, and that's obviously not good. And it's perfectly allowable for processors to create environment variables, and it's common for them to be used to do things like pass arguments to services, scripts, cron jobs and the likes. And at the moment, right, folks are talking about CGI scripts being a potential avenue of attack. Let's take a look at a really simple example. So here we are at a Bash shell, and check this out. See, we're on a CentOS 7 machine, pretty much the latest version of CentOS or Red Hat Enterprise Linux. And if we look at our version of Bash too, yep, we can see that we're at 4.2.45, so we're at risk. Now, let's define a quick variable here. And let's call it, why not? Let's call it Shellshock. And this will be our function definition. Looks a bit strange, right? But it's pretty simple. And over here, let me just throw up the basic structure of a bash function, which I've lifted from my bash scripting fundamentals course in the Pluralsight library. So we've got the parentheses that tell bash it's a function, and we put the actual contents of the function within these curly braces here. And as bash doesn't let us define an empty function, we've just put in a simple echo statement. Anyway, now for the bug, our malicious code. Let's go with something nice and gentle though, another echo command. Alright then, what we've got here is a new variable called Shellshock. Could have called it anything, right? Then we give it a string, and the first part of the string here is our function definition. And then this bit at the end, this is our malicious code. Now, we've gone easy and we've just used an echo command, so not malicious at all. But obviously, we could have put pretty much anything that we wanted here. Literally anything we want, as long as it's syntactically correct, right? Now then, because we exported this variable as part of our environment, that means any subshell that we fork off from this shell, which is probably the most common way of running scripts, right? Well, because the variable is exported to our environment, if we fork a subshell, that subshell will inherit the variable. And when it does that, bash realizes that, hey, there's a function defined inside of this variable, so I guess I better process the variable so I can place that function into my environment. Now that, in and of itself, is okay. It doesn't actually execute the function, it just puts it into memory in its own environment. The problem is though, rather than just reading and defining this function part, bash carries on and executes our malicious piece of code here. So, if we just type bash here at the shell prompt to fork off a new instance of a bash shell, so a subshell, then the new subshell should recognize that our Shellshock variable contains a function, so it'll parse it and place the function into its own environment, and then it'll execute our malicious code here. Well, let's hit enter and see if that's how it works. Boom! There we go. We just injected an arbitrary piece of code and it got executed simply by starting a new shell process. Now, a couple of things, okay? Number one, this only works if we define a function in a variable. We can't just put an echo command in there, or any other command for that matter. It only works if bash recognizes that there's a function defined in the variable. And second, okay, you probably noticed it doesn't print our dummy text here, because it's not executing our function, it's just defining it. But it absolutely does execute the code that comes after it. And that's the bug, right? Bash should not execute the line of code outside of the function definition. It should process the function and then call it a day. But it doesn't. It processes any commands that come after the function definition. So the net result here is that an attacker has a pretty easy route to pretty much the holy grail that is shell access. And they've got it to millions upon millions of machines worldwide. I mean, the majority of web servers on the planet are running Linux, yeah? Like we said earlier, that's potentially only the start of it. Linux and potentially vulnerable versions of bash are everywhere. So let's cut straight to the chase here. As I'm recording this video, there's an arms race going on. On the one side, there's the folks wanting to use this bug to do nasty stuff. They're frantically looking at ways to attack. And on the other side, there's those of us who are desperately looking to defend. Now, on the defense side of things, there are a few things that can be done. But number one should obviously be test and then apply whatever patches come available as soon as they become available. That's got to be number one. But I also want to mention SELinux, Security Enhanced Linux. Now, up front, okay, I'm going to say that even if you've been good and running SELinux in enforcing mode, it won't fix or block the bug with bash. But what it will do is limit the damage that can be done if and when our systems are breached. And while I appreciate that we're only talking about damage limitation here, it could absolutely still save your business, and it could potentially buy you a ton of time to stiffen up defenses elsewhere. And that's certainly better than nothing. So a quick primer on SELinux in the context of Shellshock. SELinux is all about confinement, sandboxing if you will. On an SELinux hardened system, processors, especially network-facing processors, get targeted and confined. And as it's a common attack vector, let's think about HTTPD, the Apache web server. When the Apache web server runs on an SELinux system, it effectively gets confined into its own little corner of the system, like a sandbox, yeah? Behind the scenes, SELinux is enforcing policy rules that say things a bit like the HTTPD process can only access files in, I don't know, let's say var dub and anything below. Meaning, right, that if Apache gets compromised and starts executing arbitrary code and the likes, it can only wreck itself. Now that's not perfect, right? I know, but it's way, way better than allowing it to swing that metaphorical wrecking ball all over our system. Now if you're still wondering, well, what good actually is that? Well, for starters, okay, sticking with our Apache web server example, well, there's a good chance that your SELinux policy will stop privilege escalation. So, stop the compromised process from raising its level of access via things like setuid. And your personal data, so stuff in your home directories and the likes, will almost certainly be protected. HTTPD can't read, write or execute files in users' home directories, and for that matter, nor can it read, write or execute the etc shadow file. The idea, remember, with SELinux being that processors get the least access possible to do their jobs. I mean, why would the HTTPD process, and sorry to keep picking on it here, but why would it need to be able to execute, read or write files in a user's home directory? It doesn't. So, on an SELinux hardened system, it can't, even if it gets compromised. The point being, in today's world, right, where computer security is a top priority, technologies like SELinux are no longer a nice to have. They're essential. I know that folks who are running SELinux in enforcing mode right now are glad they are, as doing so will drastically reduce the damage that can be done by Shellshock. But on the flip side, if you're not running SELinux, then I'm sorry, but your system is wide open, and not just a Shellshock. We should expect stuff like this to happen more and more going forward. Now all of that said, okay, I want to make two important points. First up, if you don't know SELinux and you've not tested it, don't go running straight to your nearest Linux machine and then do a set enforce 1. Do your homework and your testing first, please. Second up, knowing this about SELinux doesn't help us with things like our home routers or our other kind of black box corporate technologies that potentially run Linux and Bash under the hood. No, we don't have the ability to go and turn SELinux on those types of devices, so this really only helps us with fully blown Linux servers and desktops, but better than nothing, right? On those other devices, we need to be pushing our vendors and manufacturers for updates to fix the bug. So that's our primer on Shellshock and how we can potentially use security enhanced Linux to mitigate some of the damage that can be done. Thanks for watching and good luck with keeping your systems and data secure. My name's Nigel Poulton, and like I said, I'm an IT trainer at Pluralsight, and keep an eye on the Pluralsight website actually for a security enhanced Linux fundamentals course which will be landing very soon. Remember, security is a hot topic and we need to be prepared for the onslaught ahead. Thanks again for watching, and feel free to drop by my website nigelpoulton.com and to tune into my podcast, the In Tech We Trust podcast, a weekly podcast where we discuss what's going on in the world of enterprise technology.